There we go. There's a little bit of a delay there, guys. All right, welcome everybody. For those of you who don't know me, I'm Thomas Messerschmidt. I'm a friend at Camp's, and Camp asked me to sit in for him today to lead this meeting. I've got his agenda, so we're going to use his agenda, and we're just going to go top to bottom. First of all, industrial news. Oh, by the way, start of meeting. This is the start of the meeting, officially. I don't have his little squawk thing, so if somebody wants to make a noise or something, go ahead. Um, let's see. Boston Dynamics has a new robot, a new electronic robot. And let me get the link and I'll share that. And then Jim says he has a video to show with the new robot. So
Yeah, and I posted that. I'll show it too when you want.
Yep, let me get that going here.
Also, I got the pictures of the Robo games ready to show.
Yeah, we did Robo games last weekend. Woohoo!
Yeah, 3 days.
3 days.
I was there at least 2.5 anyway.
Okay, let me share my screen.
2 people. All right, we're letting people in the waiting room here.
Oh, thank you, Jim.
You just keep this little participants window up, right? And then
Yes,
it's
please keep it up and keep an eye on them. Okay, can you guys see my screen? The
Yeah,
one
we
with
can.
Atlas on it?
Yeah, we can.
Okay, so there's Boston Dynamics' new robot. Really a kind of a odd shaped head there with a big circle in the middle. Looks like something from what, the Lost in Space or something movie.
sorry.
Obviously, I'm not going to read this article. Oh, is that the video you have, or is this a different one, Jim?
That's probably it. It starts out with him lying down, so it probably, if you hit play, you'll see.
Yeah, I didn't. I need to reshare this.
Yeah, reshare with the audio and
With the audio
optimization.
Otherwise, it doesn't work. I remember.
Well, it can be choppy.
Gotcha.
Okay, are we back?
Yeah, I see it. That's it. It's a little choppy.
Yes, it is.
There you go. This is crazy. It's not Terminator-like at all. All electric motors now. And the old Atlas with hydraulics is being retired.
You have your video to show?
Yeah, that's the same one. So
That's the same one.
Yeah, that's the one.
All right. Well, that's about it for that then. Let's see. All right, then moving right on. That's the industry news. Any other robot news?
Oh, you want to do the games thing, or is that under different?
Well, let's anything else, and then we'll do the robo games.
Yeah. All right. I didn't have a chance to look up any other news, but
Anybody else with any news? Going once, going twice. All right, Jim, what do you have? Show us what you have from Robo Games.
all right. Let's see. Share screen. All right. So, yeah, I can show you quickly Camp's video collection of. He took a lot more pictures than I did, but So I was there with Big Orange in the Artbot row in the best of show category for me, and Thomas was in Artbot, and so he sent out the link for these pictures, so you can hopefully you're on the mailing list, you can um, check it out, but. There, of course, the usual lots of humanoid soccer and humanoid sumo bot, as well as many different, regular sumo bot and firefighting. And there was Robo Magellan and lots of art, a whole row of art bot installation. And then the battle bots. I didn't really watch the battle bots too much, just a little bit here and there. And then the tabletop challenge, you can see, I didn't attend this, but there's some good videos of it, of the tabletop challenge. And I think Mike Ferguson won uh, with a different robot this year than last year. There he is. Um, so camp takes lots of pictures of different people. And that was one day. Here's another day. This is what the building looked like, a big tent type structure, South Hall. Robo Magellan was out in a children's museum area. Here's the winner taken before Nathan with his robot Kubernetes 2, I think it is. And then some of these people, Dee Dee, and then here's Betty Nine singing um, at the station. And then some of these are Robo Magellan out sync pictures. I have some videos of Robo Magellan I posted, but it was challenging because for the smaller cars without four-wheel drive, because the grass is pretty thick there, and there were little divots in the ground and lips of curbs and roots of trees and stuff. So, you gotta ideally have the four-wheel drive and be able to take a hit when you slam into a fence or a bike rack. Here's one right here, this like an old stump and holes, and so that I didn't participate. My robot wasn't ready, but hopefully next time. Here I am, yeah, just moving the robot. I don't know why I agreed to that, but I moved it 5 feet, so big deal. And so yeah, a lot of pictures of that Robo Magellan. And then here's what the award here, our own Brian Erickson from RSSC won the bronze medal. And the Sackbot from the Martin Mason from the college there, they won silver, and Team Nathan won gold. So that was a good performance in that fairly challenging environment.
You have Nathan here.
Hey,
You want to
Nathan,
see if you
congratulations, Nathan,
Yeah,
Okay,
congratulations to all of our winners, including
and
Nate.
all of our winners.
And who else won today? I mean, over the week.
And congratulations to you, Thomas, for you got your a bronze for the for Betty Nine in the Artbot one of the Artbot categories, right?
I did.
So this, yeah, some more pictures, and you can check these out. And here's, oh, you already saw that. And then yeah, this is what the medals look like once they're
going for. I think he's
once those medals are completed, they will look like that. But unfortunately, they didn't have the insert here, the display. So those will get mailed out to the winners eventually. I'm not sure exactly when. And then yeah, here's
going for. I think
this is sort of what the I'm not sure how much do you want to play any of this, or we'll just leave this for people to play later.
Yeah, we can end off here, Jim. That's great.
Don't have
Thank
to.
you.
Yeah, so there was plenty of, yeah, I posted a few videos You know, I particularly like the the firefighting was the
Firefighting contest.
beyond Robo Magellan. There's all sorts of events like the firefighting. Watch that. You want to see a really cool one. It like the guy gets it in literally a few seconds. Watch this little clip here.
I think those are like fire sensors for the.
Yeah, but the light itself isn't.
Wow, 6 seconds.
6 seconds. Although he got lucky because he had the first room. Anyway, that's the Robo Games report.
Okay, great. Thank you. Thank you, Jim. Anybody else with any information from Robo Games?
We had a question. I had a question. The firefighting challenge, like, I know you got lucky because it was in the first room, but don't they give you like some kind of like time multiplier or something based on how many rooms you ended up having to search?
In orbit, we can't hear you very well. It's very low.
Yeah, you're probably right. I haven't read the rules, so I'm sure that has to have a handicap or something, because you know, like in golf or whatever, because you that would be unfair, wouldn't it? You know, because it's randomly the candle is moved randomly to a particular room, and you know so you're just there's luck if it's the first room. So yeah, that has to be taken care of somehow. I'm not 100% familiar with the rules, but I'm sure you're right. The rules are online on their site.
All right, thank you, Jim. We're going to move on. Next up is I Need Help. Who needs help tonight? If you need help and don't want to say anything, you can post to the mailing list and somebody will be glad to help you out. Lots of capable, very smart people here. So please do that. If you don't want to speak up tonight, you're welcome to post to the mailing list. Anybody for help? Okay, next up is show and tell. Who
So
here
we have,
has show and-
in orbit, we have 2 show and tells.
Okay,
So I
is
guess
it, that's in orbit?
at in orbit, we have 2 show and tells. So the first one is Steve Joyce, and he is grabbing his robot now. I'm going to move the camera.
So this is tabletop. I'm going towards level 1 today. People may know me. I used to come around a lot about 10, 12 years ago, and then I got doing other things. As a matter of fact, this one was, it previously ran just its shell with different electronics, its software, et cetera, and it was able to get level 2. So I hope to come back and get level 1 today and perhaps 2 and 3 later. I made this from my old robot. So I ripped everything out and I put in some new stuff. And I said, well, you know, everybody likes to give it a name. So that sounds a lot like Frankenstein, right? So I started with Frankenstein, and then it became Frank, a little more friendly. And I noticed it was a little bit larger than some of the other tabletops. So I'm calling it Frank the Tank. For those of you like background.
So there's a lot of stuff on the side there.
Sure.
Do you want to talk about that with
Sure.
sensors?
I'll talk about the board first. Underneath there's an Arduino board. The original had a propeller, so I needed a little bit more juice. So there's Arduino underneath, and this is a 293 motor controller, which it's pretty standard, like $8-10 on Amazon. One problem that they have is there's a lot of voltage drop. It's bipolar based, so there's about it's H bridge, so there's 0.7 volt drop on the top as well as the bottom. So a total of 1.4 of your volts goes to power the device. So for level 2, I'm going to try and get a H bridge from CMOS devices, which have virtually no power dissipation. So more voltage to the motor, as well as they give you a warning about this overheating. So with the lower power on the CMOS, it won't have that problem. from a sensor standpoint, this, their Arduino and the motor controller, I was a little disappointed because after you get the motor controller on, there's like 5 pins available. So I couldn't do it anywhere near what I want to do, but I have 3 pings on the right side. I have one in the front. So there's 2 here that sense the outside, and then this is intended to sense, it's intended to run along where this one says it's close, like this, and this says, okay, I'm on this line, and this says, okay, I'm over. So if it runs perfectly, it'll go just like this, which you won't be seeing today. And I did have enough pins left over for 1 red LED. So that's about it. Okay, and my hope is to come back with a Raspberry Pi and the H-Bridge from CMOS to help things out. Okay.
Let's see what happens. No pressure.
Yeah. Now I'm gonna need a couple spotters. Definitely, 2 or 3 would be useful.
Anybody go to catching robots?
Got a few in my day.
One-handed robot catcher.
Okay, so the path it should be taking is, it'll go forward just a bit, turn right, and head over here, and then left and go that way. When it gets to the end, it'll turn around and take about 45 degree over this way, hopefully, and then find this edge, and then turn over here and stop. Now, the width and the length is quite a bit different than I debugged it on at home, so we'll see what we get.
And these are ping sensors, so they shouldn't care about the tape.
Right there. Yeah. Ready? Ready?
Yeah.
Going good so far, Steve.
Yeah.
Nothing fell off. There it goes.
It turns right, keeps going, starts looking for this edge. Good turn just a bit. Or not. Oh, found the edge. That's what my LED says. So now we'll back up. Hopefully turn around. Oh, right. That's what it's supposed to do. Go back a little bit, then turn around again and aim towards here. Okay. Now, this is not what I intended, but if it works, I'm happy. And it looks like this, my money says that this one's going to work. Oh, as long as it don't. Hey, do I need to run it again?
Give it to him. Let's give it to him. All right, thank you.
Thank you very much. Thank you. Appreciate it. Any questions? Yes.
Are you using encoded missiles on that?
There is an encoded motor, but I just got the parts I needed for 2 weeks ago, believe it or not. And I had to start with what I had. And it turns out I just had the LED pin, and I think there's one other pin available. So I have the encoder on it, and I'll have it for next time. Again, graduating from an Arduino to a.
How did you know how much to turn you run the turn trip?
I programmed it to turn basically those many degrees, whatever that is, 125 to 135 degrees. So it is totally automatic. So in other words, it's gone here, came back. It very intentionally, it came back and rotated this way.
Yeah.
And then turned around, because if I didn't do that, I experienced many falls for that. So it falls off the table, right? So it came back and went that way.
And so how do you get it to turn that many degrees? Is it time?
Oh, yes, exactly. With the motors for this, you put in a speed, There's with the Shield, there's I think it's called AF Motors library, and you put in speed and time. So you pick a speed and you pick how long you want to go, and there you go. And also the sensors, you know, if it doesn't reach where it's supposed to go, then it says, okay, go again. And the last one says, if it's going straight, it'll tend to go straight unless things change. So.
Any more questions for Steve?
Okay, thank you.
Big round of applause. That was awesome. Nathan, did you want to say a few words?
The third show, no.
Nope. Go for it.
This is not a table bot. It's more so people can see it. I can put it on the floor if it's not welcome on the table, but I can. All right. All right, so this is Kubernetes 2. So this is a Broken Magellan bot. I entered it in Robo Games this past weekend and took home gold, which yay. All right, so just as a bit of background on what it is. So I started basically from the ground up with it's a Traxxas Emax RC monster truck from about 10 years ago that I had just laying around that I hadn't used in a long time. So started with that. Probably one of the first things that I modified was these RC trucks aren't really meant to carry any weight at all, like beyond just like a body shell. So the first thing I had to do was like stiffen up the suspension. So I ended up finding some like spring stock online that had the same diameter as the stock shocks. So now, you know, it still has functional suspension, but it's a lot stiffer and it actually manages to carry the body weight of the truck. There's also I retrofitted like a shaft encoder into the transmission on it, so I can actually have odometry on how far I've driven. Basically, there's one of the US digital encoder glued onto the front of the transmission box with a shaft coupler that like sticks a little shaft extension out the front of it. So there's that. There's it's brushless motor, 6-pole, like with I'm running a AM32 based motor controller. That let's say targeted for like a crawler or like RC rock crawler trucks. So then electronics wise, there is a Raspberry Pi 4 as a main computer. There is a U-Blox F9P GPS. There is this, probably my main sensor that I do most things with is there's a Luxonis Oak D Pro stereo camera that I use for collision avoidance, distant depth sensing. I also use it for the vision for finding the cone. There's just some bump sensors on the front, and there's also an InvenSense IC. There's basically a 9-axis IMU on the front. Which is this little thing plugged into the Pi. So as far as Robo Games goes, the F9P is accurate without RTK corrections with reasonably clear sky, has an error of only about 1.5 meters. So for the most part, I'm just trusting the GPS isn't wrong too much, which seems to have been fine so far. I was very scared when I thought the competition was going to be next to that building, because I spent the entire morning like testing various GPS points along, and like the average GPS error I was getting around the building was like 7 meters. So I was like, oh no, I'm screwed. It was like, and so I was running around like, okay, we're gonna have to do this whole thing based on dead reckoning because the GPS is useless. But then camp said we're moving to the park, so I was like, oh, thank God. So basically, I'm not running ROS. I'm running pretty much something I wrote myself. It's not all that complicated. It's basically just like a simple state machine framework that just takes in data from, there's basically handles in each like task. It's like on GPS, on IMU, on status packet from the motion controller, and then it just on vision packet, like, or because it but yeah, so basically just it's pretty simple. There's no like high level navigation mapping logic. It just, okay, I'm at this position, I'm going to this next waypoint, I'm gonna, okay, the heading that's required within the 2Ds, I'm gonna just do a simple PID loop to follow along that heading. The camera's running just a simple collision avoidance. It takes the point cloud, filters out anything that's not directly in the robot's way. And then if there is something, it just pushes it off of the path. It doesn't really try to map. And yeah, then it just drives a list of waypoints, and then I tell it which ones are cones, and if the waypoint is a cone, then it will stop a few meters away, try to identify it visually, drive up and drive to the nearest orange thing until it bumps into it, backs off of it, then runs to the next one. But yeah, if anybody has any questions about it.
So,
Yeah.
if you're using the GPS primarily for navigation, what do you need the IMU and the encoder for?
So I only have, so the pretty much it's the GPS only because it's accurate to 1.5 meters, and it does like bounce around, like the heading error is still going to be, the closer I get to the target point, there's going to be heading errors. So pretty much I just wanted to build in a compass just to, without moving, I know what direction I'm pointing. So it's just, there is a more reliable way of figuring out which way I'm pointing. Like, I guess since if I'm not running RTK corrections, so since I think that's technically disallowed by the competition, I don't know. Like, but I mean, I guess technically there is, if there's this one GPS that I was looking at on SparkFun. So uBlocks has it's basically a satellite receiver that if you pay them $35 a month, you can listen to an RTK correction stream from a satellite. Basically it takes where you are, and it just loosely figures out where you are, and they'll find the nearest RTK source and just stream it to you from space. So I guess technically, like, I don't know if that counts. Like, you don't have to talk to any like beacon of your own. Like, you talk to somebody else, But yeah, because there's no RTK, like a couple people, I think Marco showed me, it's like if some people are doing, if you're running RTK, you could technically have 2 GPSs and do like GPS heading since the RTK is like sub-centimeter precision, if you like put 2 antennas like on either side of your robot, technically it's precise enough where you can just draw a line between the 2 of them and know which way you're pointing. But since I'm not doing corrections and I'm in a meter, I can't really do that. So I built in an IMU. Yeah. And then I'm moving to a new IMU that I found online because that one, I think, what's the chip? It's a ICM 2948 or something, but there's really not a good, I bought it off of SparkFun, and SparkFun provides this library for basically using the onboard sensor fusion. But SparkFun basically put out a note about 6 months ago saying, we give up, we can't figure it out. So I was like, okay, not gonna use that one anymore. Because basically if you try to turn on the compass, it just spins around in a circle and nobody else seems to know why. And you also can't upload calibration data to it because you have to sign an NDA with InvenSense to get the rights to know what registers to poke. So I found this IMU on Tindy called the USFS Max. It's some guy, it was a Hackaday project, and he sells these boards. Like, he doesn't give out the software that runs on them, but basically it's a pre-calibrated board, and he claims like 0.2 degree heading error at most. So as long as you calibrate for hard iron correction, so as long as you do like the 3D like corrections, that's what they claim. But I haven't tried to get it working yet because I only received it about 6 days before Robo Games, and I hooked it up, but that's about it. So that's the next goal, is to figure out how to use that.
You might, if Adafruit makes a similar IMU to the one you were having trouble with SparkFun libraries for, if they make a board based on that same chip,
it's the same issue because it's an external group working on like an Arduino framework for that chip, and it supports the Adafruit board and the SparkFun board, and because basically that chip, I think
so it's a third party.
It's a third party library, but it's like, I think the guy who writes it is working for SparkFun.
And some boards in the past have had much better level of Adafruit libraries.
Yeah, exactly. So I think it's more like, in this case, it's more of just a lot of it, like that vendor's not being super open about how their chip works. So like, here's a proprietary blob and a piece of sample code. You don't get any engineering support. So if you figure it out, cool, but otherwise sign an NDA and then we'll tell you how it actually works. And then you can't tell anybody. And then you can't. So I'm going with this, next year I'm going to be using this US, if it works, I'm going to be using that other IMU. I'll post a link to it on the mailing list.
Is that the same camera you used last year?
It's the same camera I used last year, but this year I actually had the collision avoidance working. So it is a Luxonis OD Pro W. So it's a wide angle. So it's the wide angle version of their base one. So you get about, I think it's 120 degree field of view off the front of it, but you basically, the camera streams a depth map to you. And since it's stereo based, like you don't have as long as the sun's not directly in your face, then like it still works outside. It doesn't have the problem with the sun overloading your LiDAR. So it still has a couple of quirks, but like for the most part, as long as you like filter the output stream, it's pretty good. There's also a, what do you call it, a tensor processor like in it, so you can upload like AI models to it for like object classification. I still am trying to collect enough pictures of traffic cones to train, because you need like a few hundred of them.
I actually have a model online
For traffic cones, okay.
It seems to be working pretty well indoors.
Okay.
I have also
Okay.
distance and offsets.
Okay. I want to ask you about that later.
Yeah. Eventually, my will go outside.
Right now, I'm just doing pretty simple, like classic computer vision. I take the image from the camera, I transform it into HSV, filter out everything that isn't mostly orange, and then look for triangles. That's pretty much all I'm doing right now. This is pretty much all. So,
what are you using
just OpenCV. Yeah, just OpenCV, because the camera is the camera has its own SDK called like Depth AI, but they integrate really well with OpenCV. So even in like if you're doing like Python or C++, you can just be like, okay, here's all of their code to like, okay, now I get an image, and when you ask for an image from their SDK, it just gives you C. So and then you can just do whatever standard OpenCV work you want to do on it. I have been trying to push the color space conversion onto the camera because it does have onboard processing, but I just haven't got there yet. And I'm also gonna upgrade to a Pi 5. I tried to do it before RoboGames, but that was it. I copied all of my code over to it, and it just didn't work. I was like, okay, not enough time to figure it out. I'll do it later. But for the most part, it's 90% of my CPU load is the image filtering, like. And it's enough. And also the other big problem. So the other reason I want to upgrade to the Pi 5 is so I did play around with it a little bit, but I don't know how many people have tried to use like USB 3 for sensors on the Pi 4, but at least what I found is that it's really unreliable. Like if you like hit a bump or jiggle a cable, like it's just there's not enough signal integrity or something. So you'll sync up if you're on a table, like you can use a flash drive, but if you have like any form of like USB cable plugged into the Pi, plugged into something else, like 20 seconds, a bump or something, and it'll just like, you'll drop the USB 3 line, the connection. So if you run it in USB 2, camera's happy, but like with USB 3, like anytime I hit a bump, I'd lose the camera. But, or sometimes I just randomly lose it. But then I tried with the Pi 5 and I could like flex the thing around all the time, shake it around and never drop the connection. So that's one of the biggest reasons I'm trying to create the Pi 5 is just a better USB 3 like implementation.
Yeah, but the cream was good and that makes it much faster. It's much bigger.
Yeah.
Running my Pi 5 is 500 gigabytes is the
Nice.
And yeah, I think basically it was Dex. That's how it works.
Cool. So the other future thought for something to do that, there's the Pi 5. There's also, I picked one up a couple of weeks ago, but there's I guess everybody's probably aware of all those mini PCs that have been coming out as of late. So there's one that was really interesting to me, like enough so that I bought one, but it's called the Minis Forum EM780. But it's basically the high-end AMD laptop, like gaming laptop CPU, or not the gaming laptop CPU. It's the high-end, it's their high-end APU. Or AMD's high-end APU, so it's like 8 x86 cores, or 8 of their Zen 4 cores. It's like a 12 compute unit Radeon GPU, but it comes in a box that's 80 millimeter by 80 millimeter. So it's basically it's the long side of a Raspberry Pi, but just square. And like it just takes a 65 watt USB-C input, and you get a full x86 computer, and it's 35 watts. So I bought one, but like I'm gonna see if I can integrate it. I have to change my power delivery because I can only do 15 watts port on here, but like but something I'm gonna look at because it's so tiny. It also has AMD's it's the first one with their like built-in NPU. So I think it's like 16 teraops or something. But just stuff to play with in the next year before the next RoboGames.
Any more questions?
Said they're using this smartphone.
But yeah.
Most of the time I hear people use the MPU 6050. Have you ever tried that?
So I have used one in the past. It's the reason that I haven't been using that one is so it's a gyroscope accelerometer. It doesn't have a compass. So the 9 would be the 91, the 9250 would be the 6150 plus a compass. And so I used, I did use one of those previously, and then I upgraded this one because it was supposedly better than it sucked. So it turned not no win on my end. But the thing with the 9250 is that I don't think anybody has the onboard sensor fusion working, so you always have to do it off board. And I just didn't get around. I just wanted something because it's plugged straight into the Raspberry Pi. It was just, what am I going to work on? I'm going with this because it's all on board and it just sends
Guys,
me.
Hi there. In orbit. Thank you very much. We do need to move on. It's a wonderful robot. Thank you. Give him a hand. Yeah. First up, we have, well, next up, anybody else?
Yeah. Thomas, we have one more at in orbit.
One more, please present it because we do have to move on. And we're running a little short of time, so give it to us in a nutshell, please.
Well, I showed this one last month, so the biggest things I just wanted to show updates on it. The biggest one is I redid the frame, so everything's built off of a different screw type. And I fortified it. So what I've really been doing is testing it by driving it off tables for like 5 to 6 times. If it breaks, then I fix something on it, figure out why that happened. So yeah, that's kind of what I've been up to. And yeah, I kind of have a list of things, but yeah, it's like I did MAC addresses. So that way they don't conflict with each other, because the way this one works is it makes a AP and you drive that AP on your computer. I can turn that on to show. So turn it on. And I was hoping I could share my monitor here maybe. I don't know how hard that'll be.
It's easier if you're on Zoom.
I am on Zoom. So
If you connect to Zoom, you can share your screen.
okay, I am on Zoom.
To save time, can you just throw it off the table?
Yeah.
Oh,
That's one.
I didn't tell him to do that.
So yeah, well, right. These are floor bots primarily. They are actually just controlled. Yeah.
Oh, that's cool.
I need to do a bit more work on that, but yeah, that's kind of the gist of it. So yeah, can give some. I think that.
Looks like it's-
purposes, his name is Dan.
It looks like it survived pretty well.
Yeah, it did survive pretty well. But actually, this is one of the older versions. The thing that fell off was taped on, right? Oh, that was taped. I have, if you pull the one back here, this is the final version. Yeah, it's a screwed on bottom, so it should not. This shouldn't take too long, because let me get this driving off. Okay, so.
Not my fault.
It's this one.
You have a plan to make them autonomous at some point?
I actually do, right? And I want it to have it so that it connects to a desktop client, and the client on the computer is the one controlling it. Because I have a very, very light hardware in here. It's only an ESP cam. And what's happening here is, yeah, now I got it controlled over here. It's got a web stream. It's got arrow key controls, light. It's all happening over WebSocket. And yeah, then you can drive it around. Okay, you can drive it up the table now. And let me do like still going.
That's cool.
Yeah, so that's my goal, right? Make it like indestructible, get like a bunch of them. And I'm also thinking, I think I'm officially exhibiting it open source. I got a couple of approvals on it. So yeah, I want to get like 8 of these on a booth, have people drive them around.
So when robots take over the world, now we know what they're gonna look like.
Yeah, just tiny indestructible cheap. That's what I want. Indestructible, challenge accepted. Well,
We can test that.
That was very good.
So, yeah, any questions, I guess?
Table four table bot,
Phase four table bot.
Yeah.
fall off tables,
Fall off a table into.
So how do you make them autonomous using the laptop? How's that?
So I'm controlling it over the laptop and the laptop receives all the data. So if I can tell it from the laptop side to interpret the photos and open the video, I can also have it run a program here that tells it how to move. Right?
Okay.
And then I can start.
There's
doing-
cameras in those things? You can-
There is a camera sitting in there, so you can,
Gotcha.
yeah, you see that,
Okay.
yeah.
So you're gonna write some code on laptop that shows the camera feed?
Yeah,
and send it back to me?
Yeah, and it can be as expensive as I want it to be because it's all happening on this, it's got like an RTX GPU on it, so it's fine. Right?
Can you control more than one at the same time?
Oh, yes, I can control more than one at the same time. Now, in order to do that, I have to connect them online. So there's actually two modes on this. It can be controlled over AP or it can connect to a central relay server. And when I have two of them on the relay server, then I can control them both. So if I can do that, this one. Yeah, so this one is now, I believe, online. And once it's online, go. Oh, actually, I didn't. I don't know the Wi-Fi password here. Do you guys know the Wi-Fi password?
I forget. Chris?
Hey guys, we're running out a little short of time.
Yeah, maybe
If
next
I'm
time.
too short on time, I can just wrap it up. Yeah.
Show us that part next time.
Yeah.
Yeah,
Okay.
that was great.
Sounds good.
Applause. Thank you.
Thank you very much. Anyone else over there and in orbit?
I think that's it.
Okay, we have 3 online. Anyone else? I have myself, Jim, and let's see, myself, Jim, and who else? Someone else. Oh, Daniel. Anyone else online? We have 3
Yeah,
online.
Daniel.
Okay, I guess I'll go next. This is a real short one.
You gonna
So-
share? You sharing
gonna-
screen?
What's that?
You're gonna share screen?
I am.
I don't see it.
Give me a second. Can you see it?
Yeah, all right. There it is.
It was only 22 seconds. This is, if you weren't at Robo Games, this is what was driving everyone crazy. And that's it. Do we use, do we entertain? We do. Any questions, or we'll move on to the next person? All right, moving right on. Jim, it's yours.
All right. So I wanted to just give a quick update on my it's my future Robo Magellan robot, but currently it's an RC truck that I've tried to make into autonomous, an autonomous vehicle, at least with ROS 2 in indoors and maybe a little bit outdoors, but it is a RC car with Ackerman steering, and so it's a little bit of a different kind of planner. I'm using this thing called Teb Local Planner, and it can handle the steering of a Ackerman type steering vehicle. Actually, I wanted to show you the other video, but so this basically, it's able to back up and go forward and make these turns, the turning radius. And the robot can't turn on a dime. It doesn't do spin.
Close enough.
So that's one of the, let me show the other video quickly.
I think I tweaked it just enough.
Oops.
Let's try one more time here.
Sorry, let me get into the.
So here.
Oh, there it is. So
Truckosaurus is
so this is a picture of
goal.
I mapped with and this is Arviz and
pointing that way.
So you can see it planned a path.
It looks like a decent path.
And I've got it a model, and then it'll start going. It's using just a LiDAR. It has some delay issues, but it'll eventually get where it's going. And it kind of goes back and forth like this. This is all autonomous. So it's kind of an interesting take on
made it.
An interesting different variation of being able of navigation using a different Kuiper planner. So that's it for me. I'll give you updates as I progress on that and get the GPS working for outdoor use, etc. Thank you.
All right, thank you, Jim. Moving right on, who was that we had last? Daniel. Daniel, you ready?
Yeah, can everyone hear me?
We can hear you.
All right. So I won't be long, but I brought this robot to Robo Games last weekend. It is a 3D printed humanoid robot built for the Android Kung Fu competition. So I'll give you a quick demonstration. So I have a ESP32 controller, and it's I'm using the Nintendo Switch gamepad here to control it. So I'll just enable it real quick, put it up a stand. So, all right, and I'll just move it along. Could throw some punches. If it falls down, it can self-right, like so. And then, yeah, that's pretty much it. I'll have some like full fun expressions. Yeah, that's it for me.
All right.
Cool. 3D printed.
Yes, 3D printed.
Is that your own build, your own custom build there?
Yes, that is.
Nice.
It used to have a head, but I gave it to the Hong Kong team, so it's across the ocean right now.
Oh yes, the Hong Kong team. They have a big team with a lot of events.
Yeah.
All right, thank you very much, Daniel. Moving right along, we have a talk tonight by Sam Tagliabracci. I hope I'm not really ruining your name there, Sam.
Hey, that was pretty close. It's Tagliabracci.
Tagliabracci, okay.
A good Italian name, right?
Yeah, exactly.
All right, Sam, you're up. This is Sam from Clearpath Robotics, and he's going to be talking about his TurtleBot 4, his Clearpath TurtleBot 4, which is a whole lot more than a TurtleBot, right, Sam?
Yeah, so hello everyone. My name is Sam. I will kind of share my screen and give you a quick little introduction to so I'm from Clear. Can you guys see my screen?
Yes.
Should be good. Let me slide this over. So I'm from Clearpath Robotics. For those that don't know, We're one of Canada's leading robotics engineering companies. You can see on the screen some of the different platforms. We call them base platforms that we build and deploy. Our customer base is primarily like researchers, roboticists, and universities. And as you can see from the screen, we have a multitude of different platforms. About the company, we actually started off pretty small. Let me see if I can find the story. It was started by here we go. It was started by four university friends that were mechatronics grads, and they actually started it in their basement, and the company has grown from that. Basically, their goal is to kind of deal with the dull, dangerous, and dirty kind of jobs, and try to implement robots into them. So yeah, this is a company. Before I jump into my projects, I'm going to tell you a little bit about their different platforms. Let's see here. Yeah, so let's start with these guys here. Yeah, so I'll introduce the fleet. We'll go maybe smallest to largest. So yeah, the Turtlebot 4 is one of the newer members. Yeah, so it comes in two form factors, which we call the standard and the light. They have the little RP LiDAR, they have the OT cameras. The standard we kind of pack in sort of like a upgraded board. Yeah, yeah. So this is actually running ROS 2 Humble, which is a really good way to jump into the, ROS 2 environment for like a pretty cheap entry point. The second one on my list is the Dingo. What's nice about the Dingo is it comes in the Omni wheel flavor. So this thing can strafe, it can go, it can turn, it can go forward, backwards, all directions. And it's actually a pretty small platform. I think it's like just over like a meter in length. Or sorry, half a meter in length. So yeah, it's quite a small little platform, and you can upgrade it with all kinds of cool sensors like Velodyne 3D LiDARs, IMUs, 2D LiDARs, even some manipulator arms from Canova. Yeah, these are some of the integrations that we do. And so my role in Clearpath is I'm on what's called the complex integration team. And my role is both an integrator and a software specialist. And so what that means is that I have to do not only the software, but I can also do the mechanical engineering and the electrical. So to be a roboticist, you kind of actually need like a good combination of all three, along with some creativity. So the next one is a Boxer, and this is kind of a more industrial robot. It's robust, it's heavy duty. This we actually stole from our sister company, which is called Auto Motors. They were derived in 2015 when Clearpath identified the need for what are called AMRs, material handling, basically. You can see that we're moving a lot of like pallets, there's automated forklifts, stuff like that. So they created an entire division dedicated to that industrial space. So yeah, the Boxer is basically a rebranding of the smallest robot, which is, let me scroll, yeah, this guy right here, which is called these are the different versions. So it's called the Auto 100. So they have different payloads, like this one, for example, can lift 150 kilograms, which is actually pretty heavy. These are the two newest models where we tried to kind of find a middle ground for people that didn't quite need the full heavy duty 1500. So we created, updated versions, and these are good for both Europe and North America. And then the final one in the auto fleet is the Lifter. So that's a kind of a quick glimpse into auto. Any quick questions about any kind of questions before I continue on?
Yeah, are your lifter, does it lift up pallets and such by itself?
Yes, sir. Fully autonomous. So it's got what's called the indoor nav stack. We have like the autonomy stack. Let's see if I can get a nice picture of that. Yeah, kind of sort of looks like this. You can basically set, like if we were in a factory setting, you can set like where the pathways are. If there's like one-way traffic, two-way traffic. Even you could flag like zones which are kind of like don't congest or like do not enter. You can kind of set zoning. Yeah, here's kind of what the fleet manager looks like. So you can see you could create almost like a trade route from your shipping dock, move those materials to your work cells, and then move the finished product to like the outbound shipping dock. Yeah, see like outbound in the lower right here. So maybe you want to stop by quality. You can program all these kind of trade route like functionality. So yeah, those do lift pallets and they do it automatically. So coming back, I'll jump into, so these are kind of like the small indoor platforms. Oh, sorry, the Ridgeback is also indoor. So Ridgeback was to basically answer a requirement for medium size, like, two arms on a platform that's also omni wheel, so it can move in all directions. The Ridgeback actually, answered that. And actually, I probably have a little video I could show you something kind of cool. I'm hoping my sound will work. I'm on Linux right now, so let me see if I shared my Linux sound optimize.
Make sure you click the little buttons that'll give the
Yeah,
sound. Otherwise, the sound usually doesn't come through.
yeah, I have share sound on, but I find sometimes Linux unfortunately gives me a little bit of grief. Let me know if you can hear it. Can you guys hear that or no?
Yeah.
Yeah.
In the background, there's my friend Jeff. He's like one of the legendary integrators. He's been there for over 10 years. It's actually me in the background, funny enough. I think this was shot like a year ago. Yeah, so some kind of highlights of this this video were let me pause the sound here. So yeah, some kind of highlights just talking about it. So this is one of the robots with the dual arms. If anyone's following the Aloha projects or the RT one, sort of like camera vision and adding AI, this would be like an ideal platform to kind of do that kind of work. That right there is probably one of my absolute favorite cameras, the Stereolab Z2i. You right out of the box, you can do so much stuff. You can do body tracking, you can do object detection, just a phenomenal library. This is absolutely one of my favorite cameras. You have a 3D, I think it's Ooster LiDAR on the top there. Let's see what else. Yeah, you got the Hakoya 2D LiDARs in that, the Robotique two-finger grippers. So and also the lifter, this entire base of this thing can actually raise and lower so that you can grab like things off the top shelf or the lower shelf. So yeah, this was a really cool little integration with a lot of potential. So what's that?
A physical one in the
Yeah,
real.
we have a jackal and we're in this location, we have a Auto 100 next door that has the cart lifting mechanism set up right there.
Oh, that's awesome. Yeah. Yeah, the Jackal, okay, and I'll probably jump into that next. The Jackal is a very fun little robot. It's super fast. Um yeah, it's super quick. Let's see here. How am I gonna get there? I gotta click this. Yeah, the little Jackal. I actually used to love, so I actually started building this was the very first robot I built. And it was such a cute little robot. It's essentially like a little box. It's got some cute little wheels and then these like speed fenders. And it's actually super simple robot. I think it was like 2 meters per second is like its speed. So it's pretty bursty for like a little guy. Um, and just like a good platform for kind of like indoors where it's not too big. The truth is like even the Husky is quite big you know to use like indoors unfortunately. Um but it's a great outdoor platform. It's got like the big kind of tractor tires. So this is yeah, this one here, I think they got some Wi-Fi stuff. They got some Val9s and some LiDARs. And we really like integrate the heck out of these things. Like, yeah, here's like a better example. So we actually put two UR5 arms that looks like. So they can, yeah, with the huge grippers, if you look at those are the oversized grippers, the 3-finger grippers. So that was a really cool project. Let's see if there's any other fun ones. Yeah, there's like a small fleet of them. One interesting fact about Clearpath that I found was that they actually have, let me see here, I found some fun facts. Yeah, Clearpath allegedly has robots on every continent, including Antarctica. And we did a really cool Warthog project, which had all kinds of LiDAR and sensors and stuff like that. I think it even had a ground sensing one it was kind of measuring like the glaciers and the melting of the ice and all that kind of stuff. Um, so yeah, that's pretty much our platforms. Oh, the last one is what's called the Warthog. Let me see if I could get back up here. Which is it's actually technically the second la largest robot in our fleet. So this is about the size of a small, like an ATV, I'd say pretty much. It does come in the tracked format, which I will show you. Yeah, here's a quick little video. I'll wait for the ad to pass. But yeah, the Warthog can come in the wheeled version and also the these are called the Argo wheels. We also have like turf tires, which are a little more like kind of car wheels, but a little off-road. And then we have the tracked version, which I'll show you guys right now. Notice the towing hitch. Yeah, so one really so that is does feel like a tank. Honestly, I've sat on it, I've driven around like the parking lot and on the grass sitting on it. It is like a real true beast. It could definitely squish you in an instant. Yeah, it's really powerful robot. So one cool thing that I did, one of my last projects was called VT&R. And this is from the University of Toronto. And what they basically wanted to do, well, it's a little loud, sorry. I'll just maybe turn the volume off and then I'll talk. So what this is a very interesting way to approach it. It actually doesn't need to have any of this stuff like LiDAR or GPS or any of those like very expensive sensors. It really just uses camera data, and it has like kind of like an algorithm which is somewhat similar to vectorizing, where it can take images and like landmark like areas, and so it actually recognizes like land formations to figure out where it is, which is like kind of actually like crazy that they were able to do this. And so yeah, I was involved with the project that we took one of the warthogs and put this technology on for them and got it working. So yeah, this, I guess the takeaway is that you can do some really cool things with these robots. And kind of like your imagination is like the limit. The last video I'll show you in terms of Clearpath is a quick little one about,
but if you still think
here, I'll pause that. Is about autonomy. So one thing that Clearpath has been pushing recently is the autonomy of indoor and outdoor nav. And so this was done, I think, yeah, like a year ago, where it was kind of like a proof of concept of like, can we actually do autonomy? Can we achieve it? Like kind of like a MVP.
Hey everyone, I'm Maddie Thompson from Clearpath Robotics, and this is the Robot Spotlight, our new series where we show off some of the coolest and unique robots that come through our integration shop. Now in today's video, we'll be exploring our outdoor autonomy software package using this Polaris gem, and we'll be doing this by taking this robot through the local Starbucks drive-thru to get some coffee for the team. Let's get started.
I guess one takeaway from this that why I'm showing you guys this video is that it's kind of like a little surreal to be like, these are my friends at work, like, and we did this. Like, it's not like Tesla, some big multi-billion-dollar company or something like that. It's not GM, it's like us.
To do autonomous vehicle research, and they wanted something larger than our typical base robots. So we chose a Polaris gem. It's an electric vehicle that we can control using an off-the-shelf kit, where we convert its CAN bus messages to ROS. And then finally, we've added a computer, sensors, and outdoor navigation software to help with their research.
Sounds great. Could you give us a tour of the sensors on the robot?
Sure. So with outdoor nav, we have our 2 GPS sensors up at the top. We also have antennas for Wi-Fi and e-stop. And then towards the front, we have a Velodyne and a Z2i camera. Both of these are waterproof sensors. So we have LiDAR, 3D LiDAR data, and then also 3D computer vision for doing recognizing signs or people. Not things that we're supporting in outdoor nav currently, but our customer plans to do research with these things. Then towards the back, we have a computer enclosure as well as another 3D LiDAR for when we're having to back the vehicle up autonomously. So inside this electronics enclosure, we have our main computer, which is sending ROS messages to that off-the-shelf kit that I had mentioned. We have the receivers for our GPS modules. This is a PoE injector for our axis camera, an e-stop module. There's several controls devices for things like our stack lights or buttons inside the robot, Wi-Fi, audio, and then finally some power distribution and power supplies.
Can we see what's inside the cabin?
Sure. So it operates like a typical golf cart. It has an accelerator pedal, a brake pedal, and a steering wheel. The main differences with that is we've added a motor to the brake pedal so that we can actuate it with ROS. Similarly, the steering wheel has another electric motor that is connected with ROS. Other devices, we have a touch screen back here that will let us turn on and off power supplies. There's a regular computer monitor connected to the computer at the back, which lets us see the outdoor nav software interface with any other ROS commands, so command line, Firefox, other tools like that, anything that you would have in Ubuntu desktop. A keyboard just to interface with that. Other devices, we have an axis camera, which will show up in the outdoor nav software as a teleoperation window, so you can pilot the vehicle. And finally, there's an e-stop button in the cabin that will disconnect the the CAN bus to ROS kit so that when you press it, the vehicle will coast to a stop. There's a similar button on every corner of the vehicle.
Wow, sounds great. Now, do you think we could use it to complete a coffee run through the Starbucks drive-thru?
I think we could.
So I'm here in the Starbucks Plaza with our autonomy developer, Jose, who's going to walk us through today's mission.
Thanks, Maddie. So today we'll be sending the Polaris Gem, which is behind me, on an autonomous mission to Starbucks. We'll be using our Outdoor Nav software to do this. Our Outdoor Nav software uses a GPS-based localization solution to navigate through the environment. This uses GPS data, IMU data, and wheel odometry data, and fuses all of these together to get accurate localization. We'll be using our web-based user interface to place waypoints along a planned route and then send the robot along this route. Once we get to our destination, we'll be switching over to teleop, and through the same web-based user interface, we'll be able to teleop the robot through the drive-thru.
Sounds great. Let's go get some coffee.
Let's go. We'll start by opening up Outdoor Nav's web-based user interface. There are a couple of ways to use the user interface to generate your mission. We can place waypoints by simply clicking on locations on the map, or for more accurate path generation, we can manually drive the vehicle and drop waypoints at its current location. As we begin driving the vehicle, we create a new goal by clicking the yellow waypoint button on the bottom bar. Every few meters, we can then click the red waypoint button to extend our current goal with the vehicle's new position. As such, multiple goals can be generated that will navigate the vehicle to the Starbucks drive-thru.
I taught my client Summer here how to use webinars to generate clients online.
Yeah, so so that's pretty much oh, it looks sorry, there we go. Yeah, so it's really cool how like the vehicle is just kind of like autonomously driving. There's some of the LiDAR data. It looks like he's got RViz up.
Live vehicle data, including velocity, network signal strength, e-stop status, camera feeds, state of charge, and more. Using the built-in teleoperation mode, you can also operate your vehicles remotely using an on-screen or physical joystick. Vehicle operation can be conveniently switched from autonomous mode to teleoperation mode, and vice versa at any time during the mission. Additionally, you're able to build and expand on our autonomous navigation system using an application programming interface. By doing this, you can integrate your own custom ROS-based applications, graphical interfaces, or even connect third-party fleet management tools. Hi, can I get a caramel frappuccino and a strawberry
and
cream frappuccino, please?
I've never seen one of the vehicles before.
Yeah, we usually do smaller robots, but this is the first kind of bigger golf cart type vehicle. Yeah.
So yeah, let's kind of just fast forward, but they actually did it. They actually did it. And what's interesting, this was like it feels like actually more than a year, it feels like a year and a half ago. To kind of give you some basis of like how long ago this was, I think we were on version 0.6 of the outdoor autonomy software. And now we're at 0.12. Like the amount of stuff that we've added to the autonomy and the quality and just the speed and the calculations and all that stuff is actually phenomenal. So yeah, is there any kind of questions about ClearPath or about what I do? Anything to that nature?
How big is Clearpath now? How many employees work there?
That is a good question. I think we're around the 300 and I want to say 70 mark. We actually have been hiring like crazy, to be honest, and that is one thing I could actually mention. If you are interested in robotics, um, so one thing I will tell you in ClearPath's history, if you don't know, if you check the caption of this one, Rockwell completes its acquisition of Clearpath Robotics, and this happened, yeah, around August 4th of last year. So this was huge. ClearPath was a startup that, like we said, I think it started 2009. Yeah, founded in 2009. That's correct. By these four fellows right here. And so all startups, there's, a path line. You get your Series A funding, grow the company, scale the company, get your market cap. They actually did it. They actually did it. They didn't go bankrupt. They actually were bought out properly by a company that was looking to expand into the AMR, the industrial material handling, scene. And so, yeah, this is like a full article on basically, how it went down, and everyone's, quite excited. Matt Randall, CEO, this is like a life dream basically for these guys. And so Rockwell, if you guys don't know, is like a huge titan in the States for control automation. So essentially we are part of a 30,000 large company now. But like I said, the ClearPath itself, essentially Rockwell has marketing departments bigger than our entire company, to be honest. So there's a little bit of culture shock in terms of going from sort of a small startup to Titan. But we've gotten through it. It's been pretty smooth transitions so far.
Are you friends with any of the founders?
Yeah, oddly enough, I actually live right around the corner from Matt Randall. I'm personal friends with Brian Webb and Garrick P. Like we're always talking AI.
Interesting. Those
Yeah.
robot arms you showed a little while ago, is that your own product or did you add that from somebody else?
The arms, the best manufacturers for arms are Universal Robots. This is in my opinion, but the Universal Robotics makes fantastic arms, all shapes and sizes. Here's the latest one. So it's called UR5. I think this basically means how many kilograms it can hold. So yes, or sorry, UR30. So the smallest one of their lineup is the UR3. The 5 is kind of like the mid workhorse, the 10, the 16, and the 30 being the biggest one. Oh, it looks like they got a 22. So the 5 is like by far the most common arm that we use. It's, lightweight, it's adaptable. I mean, I wonder if I have a video I could show you on this if they don't have one here. But you will see these all over industry. Like this is, in like, Google Colab videos and like, all kinds of roboticists across the world. The other major brand is the Canova. Yeah, Canova Robotics. And these are also Canadian-based company. I think they're from Quebec, I'm pretty sure. I personally really like these arms for one reason, as that they really don't give you any fuss. Let's see if this video is any good.
Every day, machine builders and industrial end users face complex challenges. But what if it was all made simple by a state-of-the-art automation solution? An industrial collaborative robot, truly designed for ambitious leaders. Modular, versatile, customizable. Introducing the Canova Link 6. Its ability to work safely alongside humans is core to Canova's philosophy, and it's only the beginning of what makes Link 6 extraordinary. It incorporates the power and compatibility demanded by today's industrial community with up to 9 kilograms of payload, a maximum speed of 2 meters per second, and a large operating envelope. It has a safe design with multiple...
I'm just gonna pause the video and let, track it back, but 2 meters per second is pretty fast for an arm. Like, to be honest, like you know, you might, yeah, it's actually quite fast. So what's really nice about the Canova arms is that they really have no fuss when it comes to a lot of like the safety. Sometimes you get into traps where you have to, you know, activate the safety, hold these 2 buttons, and like, you know, kind of like enable the arm, take it off like the locks. Like some of the arms have like, you know, this sort of safety procedure stuff, which although is great if you don't per se know what you're doing super well. But for those of us that just want to boot up the arm as part of a robot, bring up and jump right into doing stuff, and it's actually kind of annoying to have to do like a lengthy startup procedure every time, especially when you get into like wireless e-stops and then they run out of batteries and then everything like shuts off and you're like, you know, it's like, oh, that sucks. Now I got to stop my work because I got to charge the battery. You know, when you're actually working it, like it sounds great in terms of like, yo, it's safety, it's approved, it's, you know, safety approval, whatever. But if you actually work on this stuff for like 8 hours, it's kind of annoying when your batteries run out of your little e-stops. So I actually am kind of like on the, I guess, the bad boy side of like, I prefer a minimal amount of security and safety. And so I do love the Canovas because they give you a lot less hassle. You pretty much can apply voltage and they will just start up, and then you just launch your ROS drivers and they are good to go. The URs are probably the second. There's something called UR caps. It's kind of like a feedback thing where you have to kind of unlock the arm and all that. And then the last kind of manufacturer that we use a lot is the Franca Emica. Oh, I'm at there. Yeah. These guys are from Germany, and they had a bit of turmoil, unfortunately, with their company. There's some stockholder issues, but it seems that they've kind of sorted that out. The glorious thing about their arms is they have a 1000 hertz kind of like feedback. And what that means is that you could actually shake this robot's hand and comfortably know that it feels every what's called effort. So if you push on the arm, any like slight variance, it can actually feel that in extremely fast, you know, sort of update frequency. And so it's considered a very safe arm. You'll probably see these a lot in health, you know, health sciences and, you know, AI with health, that kind of stuff. Because in my opinion, it is the most safest arm available. Super cool too, if you ever want to feel what it feels like to use an exoskeleton. See how this guy's pushing the 2 little buttons there? When you do that, it activates kind of like a free move. And so I had a project where I had 2 of these, sort of like that Ridgeback robot I showed you guys, where it was in the stock room. But essentially I wrapped these things around me like an exoskeleton. I was moving them around. Yeah, it was unreal how smooth they were and how they felt. You know, and I guess I should name too, there's the Kuka, which is obviously a huge brand. They're a lot more industrial, a lot more heavy duty, but oh my God, they're so hard to program in comparison. And then I think there's like AVB. uh, oh, wow, I almost went the wrong area. AVB.
Yeah, there's also, Sanic.
Yeah, I was gonna mention them. I've seen them around the industry, but in honest truth, I don't know why, but we don't use them. Or I'm not sure if they just don't have a lot of raw support. I really don't know. I heard they were one of the biggest brands though.
They're also really scary. I arm wrestled one and lost. So one other arm that is worth looking at is the X arm. So just X is an X-ray arm. Yeah, so the X arm is gonna be the factory one. Yeah, so the X arm is gonna be, there it is, the 6-axis one from Robot Shop. The X arm is gonna be the cheapest one you're gonna buy. You can buy a 6-stop X arm for, there you go. So they're the cheapest one you can buy. They do have some issues. They do have some issues, particularly with like power off, so they can't really. There's some issues with that, but they're good otherwise. So another question for you: do you have a holonomic base, like a PR2 style base, where you have like power caster or mechanic wheels?
Yeah, okay, so I caught some of that. Can you say it? It's just with the echo in the room. Can you say it one more time?
Where's the mic? Oh, there's the mic. Yeah, I'll walk up to the mic. So do you have like a power caster style base or a like a PR2 style base or mechanism wheels where you have like 3-axis drive where you can go side to side and forward and back in place without turning?
Yeah,
Or is there
we so this Ridgeback platform, I don't know if there's any pictures I can get of showing you the Mecanum wheels, but they're Mecanum wheels underneath here. And the Dingo, this one here, this little guy here, has Mecanum wheels. Let's see if it
okay,
says it.
the mechanism wheels thing? Okay, cool.
Yeah,
Yeah,
so
and then
those two platforms have it. We actually did a hack day. So one thing that's really nice about Clearpath is they're pretty good about their hack day projects. We typically, like, if you have interest to do something a little bit crazy, you typically have a opportunity to do it. So we actually took a Husky UGV and my friend Jeff, I'm pretty sure he 3D printed them. I'm not sure. They actually, maybe he bought them. Some part of it was 3D printed, but he actually threw Mecanum wheels, and it was actually super funny and strange. Like it was almost like uncanny to watch this like Husky do these like crazy side strafes at like 2 meters per second.
Yeah, no, that makes sense. So back in like 2012, we had PR2 from Willow Garage, which by the way, Clearpath serviced for a while. But we had that thing go and buy us a coffee. So if you so you'll see it. We got it to go to the coffee shop and buy a coffee. So one thing that would be cool is if we could get that happen where your car drives a PR2 to Starbucks, and then the PR2 autonomously goes in and buys the coffee and takes it out. Because then you can we had full automation with the robot actually talking to the clerk and stuff. So it'd be cool if we could get that happen with the coffee, the full tool chain for coffee delivery.
So interestingly enough, we do actually have a PR2 in our lobby. We've kind of placed it behind the desk as like a pseudo receptionist. Um, the only so I do remember there was like ancient stories of people that I remember there's a one coder and I think he got the camera to mimic. So whatever your real life arms did, the robot arms would do. And I remember my friend Wes was telling me a story how there was a competition to like cut the ribbon. I think they had just moved into the what's called the Randall building, and they're trying to cut the kind of like grand opening ribbon with the PR2, and so everyone had a try. But that robot still is in the lobby. And every once in a while, I look at it and I think I'm like, if I was to put in like a modern motherboard. I'm not sure even how the subsystems work, but I've, just figured out if it would be worth like revitalizing it. And I guess I'll jump into something like, yeah, like so we could potentially do that. Like honestly, there's nothing really stopping us.
Yeah, no, it's all EtherCAT. No, but it's all EtherCAT motor drivers and then a like a dual xenon. But by calculation, the motherboard and the system is equivalent to a top range NUC now.
Yeah. Yeah, so like you could definitely do that. Like, you could definitely look into it to see if it's like hackable, if you could modernize it with like ROS 2 or, you'd have to write a lot of stuff yourself, but definitely like that is the benefit of Clearpath is that it's sitting there and nobody would be upset if you started poking at it and kind of like modernizing it.
It's a pretty big job because I believe that it has what, two big desktop CPUs running what, in Ubuntu 12 or something.
Yeah, you would definitely like I'm not sure how
ROS
much of this.
Electric.
Yeah, like I definitely would not personally ever jump back to like ROS 11 or anything that old. If I could, yeah, if I could modernize it to like ROS 2, I actually would consider that.
Just updating the URF would kill you.
Yeah, as long as I have like a CAD model, honestly, it's like I'm pretty fast at that stuff. And so okay, so if I were to take it in that direction, I would definitely like I'm not sure if there's speakers on board, but I would definitely put speakers on, make sure there's a mic, make sure the cameras are up and functional. And I'll show you where I would take it. This is a funny little video I did, I think last year. I'll play this for you. So this was a hack day. To be straight honest with you, I didn't want to do it. So my friend Jeff, like he's like the we call him the grandfather of integration because he's been there since the start. But he wanted to add extra odometry to the Turtlebot, and I'm thinking why, right? I didn't tell him that, but I'm thinking why the heck would you want to do that? Like, who cares? It's got like one sensor for like a mouse basically on the bottom. It's like good enough. But he really wanted to do it. He told me I'll buy the mouses, I'll 3D print a like holder into that, and he's gonna do all the mechanical and electrical work. He said, can you just do the sensor stuff and software stuff and shove the extra odometry into it? I said, okay, fine, if you really want to do it. So got hooked into it, and so he was working on that. So I started playing with the Turtlebot, and and then all of a sudden I made this. I'm an AI enthusiast, by the way. That at the bottom was his extra odometry.
Hey, are you okay?
Yes, I am okay.
How's your navigation systems? Are they online?
My navigation systems are not operational. I am seeking assistance. I did not mean to hit that. I am so sorry.
I'm gonna try to fix your navigations. Can you try to undock?
That's a Frank arm, by the way. This is my office.
Explains a lot. How long have you been here?
It looks like your navigation's back online. Let's take a look at your motor.
I must avoid the cliff. What are you doing it? I'm trying to repair myself.
Let's see if your sensors are working.
What do you know? It must assess the situation and find a way to safely cross the cliff.
Are you dangerous at all?
I am not dangerous at all.
What planet did you say you're from?
I am from the planet Clearpath.
How far is that?
I do not know.
It looks like your navigation systems have been fully repaired. I think you're going to be okay.
Now that my navigation system has been fully repaired, I think I am going to be okay. Thank you for your help. My systems are failing. I need help.
So he would always freak out whenever I picked him up. And what I was doing is I was translating his kidnap sensor, like the real bumper sensor, the cliff sensor, to like kind of like real active statuses.
Do one final test. Let's see if you can dock.
This was what I call the response analyzer, where I would use an LLM to analyze my sentence and see if there's any actionable items. Then it died. But yeah, that was a fun little video I did. So yeah, so I guess the potential there is you can, embed AI into it. That was basically the point. You can do GPTs, you can do, there's some whisper in there to transcribe, and then some vocalize out. So yeah, I think that's pretty much my presentation. I hope you guys enjoyed it and learned maybe a little thing or two. And like I said, if you are interested in doing robotics, feel free to apply to Clearpath or Auto. We are definitely hiring.
Thank you very much, Sam. Thank you very much. Everybody give Sam a hand there. And questions. Do we have some questions for Sam? Okay, I'll start out with a go ahead.
What do you think is your most specialized skill when you're working on robots?
I want to say honestly, curiosity. To be fully straight with you, when I started in Clearpath, I actually had never touched ROS. Um, I feel like I thought at the time, so my career previously was IT, like I have my own IT corporation. I've done that for, oh geez, like 20 years or so. Um, I felt like I wanted to kind of try something new, and so I was always interested in robotics. I thought it was the future. I think what really helped propel my career is just a strong curiosity, even with the AI stuff too. I find that I'm spending a lot of time, diving deep dives into the machine learning, the perception stuff, like the yellow, visualize object detection. So curiosity is definitely like super important to have. And then the next, and what that translates to in skill, I would say you actually have to be kind of generally good at many things. Like sometimes, like if you're applying for jobs, they're like they want a computer program or like a programmer, and it's like you need that very deep, like lifelong, university level programming. With robotics, you kind of need a blend of like mechanical electronics, or sorry, electrical and electronics, and also the software. You have to be versatile.
Okay. So is Clearpath using a lot of Gen AI, or is that just your a little addition to it for fun?
That is 100% me. I feel like I've been on the AI bandwagon since like December of last year. I wanted to show them, let's see that video. I think I released this in May of last year. Yeah, it was May the 4th. That's correct. So it actually was May the 4th, the whole, the Star Wars date that was happened to be released. Um, so yeah, like I'm big time into the AI stuff. Like I do everything from graphics gen, like pretty much anything under the sun that has to do with AI, I will like I've explored. And so I'm in the process of creating demos that embed AI. And oh, I didn't actually show you my latest robot. I can show you guys really quick. Sorry if I'm over time. If you don't want to see, if you need to go, I totally understand. But I actually hacked together a little turtle bot. And let me see. I'll put it. Let's see here. Yeah. So this little guy will drive around my house every hour, doing his little Star Wars patrol. Yeah, consider that your little bonus feed. He's powered by a I think Camp maybe has shown something like this, but he's got his full navigation stack, and I add some custom stuff. So he'll undock, he'll do his he'll do his little patrol with his music, and then he will redock and charge up for a bit, like till the next hour. So yeah, it was kind of like a little dive into sort of like programmatically controlling the different stacks, if you will. And so I think if where I basically what my goal is that I hope to use that, I call it the GPT pipeline, or stack, whatever you want to call it, where you can use your voice, whether it's you're speaking to the robot, maybe you're speaking to your phone, or maybe you're speaking to the controller, like a PS5, sorry, DualSense 5 controller. Wherever you get your microphone in doesn't really matter because it's all converted to ROS topic. And then it gets transcribed into natural text. And then after that, it goes to a LLM, GPT. And then after that, it will process it for response, sort of like how should the robot verbally respond and how should it respond action-wise. Um, and so essentially I'm growing this little robot. Right now he's has what's called the Nav2 stack, like basically the navigation stack. He's got the LLM GPT stack. After this, we can move on to perception, where as he's driving around, he can he can, identify objects and he can respond to them. He can like if it's a person, we can do facial recognitions. If it's myself, he'll say, "Hello, Sam. How's it going?" He'll if it's if it's I don't know, if he runs into like the TV, he will know, he will have as part of his LLM input that what is in the scene, for example, a TV, a coffee table, a laptop. And so he will know objects in the scene, which can give him a little more, dynamics in terms of like, you know, what would be the stage after that if he was, well, this little guy's not really big enough for an arm, maybe a super lightweight arm, but ultimately you could add what I would call the manipulation stack, where he could, once he has perception, he could pick up objects, you know, and interact with them, push buttons, open doors, whatever, that kind of stuff.
Very interesting, Sam. Anybody else have any questions for Sam?
Yeah, what on the robot you just demonstrated, where's all that running? Is that all on a Raspberry Pi?
That is a tiny Raspberry Pi 4 running all of that, which is crazy. I don't know how I did it. I did one of the first things I coded was a package to be a resource monitor that I publish out CPU memory network traffic. So I'm constantly, like, that's one of the topics I'm constantly observing as I add stuff like the vocalization, the nav2, like as I add more and more to this robot, I'm like pretty much constantly monitoring it. I'm hoping the OAK-D will pull through for me, because I hear that there is a lot of onboard processing, which I will 100% have to try to utilize to get good perception.
So that's a Raspberry Pi 4 on a Create 4 base.
Yeah, that's a Create 4. It's offered as a package. You can probably find it on, am I still sharing my screen? Yeah. Robot Shop. I think they sell them. Yes, sir. Yeah, I think, yeah, here it is. So looks like it's going for about $3,000 for the, like, the Pro model, and then I think the Turtle Bot Lite is about 1.8, and this is Canadian, not American. So, you know, if you guys are American, I think it's actually a lot better for you guys. I think the exchange rate is pretty good. Yeah, it's about 13 US.
Which large language model are you using, and is it local to you, or are you using like OpenAI and API calls?
So I actually use all of them. I programmed a package that is you can select your backend. So my favorite ones, actually, the OpenAI's ChatGPT is really good for this purpose, because it's a nice clean chat and it's really good in keeping in character. I like the GPT for all. I used to actually use one called Superhot, Wizard. I think it was like Wizard, Superhot. Oh, that was like the most glorious like LLM, but it got outdated. It was like second gen sort of LLM, and then the new kind of GGUF kind of format came out. So I'm rolling with geez, what the heck's it called? Yeah, it's called like news. Let me try to find it. This is the one. Yeah, so I also use Olama. Yeah, this one here, News Hermes 2. That's the one. This one's pretty good.
You're running that through GPT for all or something else?
Like I said, I actually coded it to be able to handle whatever backend you want to throw it at. So you can just select OpenAI, you can use GPT for all, and you can use Olama. Personally, I had better success with GPT for all. I'd like my friend, like I have my own little robot club. They come every Thursday. So my one friend just like loves Olama, just swears by it. But I kind of prefer the GPT for all. I don't know, it just was a little simpler to program with for some reason. But they're both pretty good. I haven't touched Claude. I hear a lot of good things about. Oh yeah, this was it, Wizard LM Uncensored. But I was using an older version called Superhot. But I guess this is a new one. So I'm not sure if I've tried it. But yeah, they got tons of. These are all local LLMs for anyone who isn't recognizing this stuff. There's all kinds. Some of them are good for programming, some are good for storytelling, some of them are just generally good. There's a whole bunch of statistics on each of these guys. Where do they hide it? It's a GitHub. Yeah, and all this is free, open source, which is beautiful. but there's charts somewhere in here that shows the kind of comparisons between the different LLMs, which ones are good at math, which ones are good at, yes or no answers, which ones are good at, such and such. But yeah, answer your question, I will use anything that is good, basically. It just, as long as it proves itself, stays in character, kind of my I mean, if you guys, I mean, we're getting into the late hours. If you guys like want me to show you some cool stuff, I absolutely can. Let's see if I can sign in. See if I can.
We have to end off pretty soon here, Sam.
Yeah, if you want to wrap it up, I'm totally okay with that. If you actually are kind of interested in some cool stuff, definitely,
Bring you back another day, Sam. How's that sound? Or just join us next month and we'll make some time for you.
Yeah, that sounds really cool.
Yeah, you can give us a real nice show and tell for a few minutes.
Yeah, I don't want to bore you guys. I mean, I don't
You're
know
not
who's into
boring
it,
us.
but
I'm eating this up. I'm really
yeah, that's good to know.
oh, just one last
We got
question.
guys on the East Coast.
Yeah, I know. It's midnight for him, huh?
Yeah, I mean, I'm a bit of a night owl, and I don't have like a tight, I don't have to be at work at 8 a.m. They're pretty flexible there. Um, but yeah, this is something, conceptual that I use. I call it the response analyzer, and essentially, I feed in a bunch of stuff like, who the robot is, what kind of mood, what's the environment, and I send it sort of a prompt from, and then this is what I expect. I expect out like YAML of like, what's the topic, what's your action, or sorry, what is the requested action? So in this case, I said ready to die human from an orc, and so it's like and then it can choose what it wants. Is it going to run away? In this case, it chose to fight. So it tells you about the subtone, and the subtone can help tell about the mood, like what is the response going to be like. And it gives like some, it's all YAML formats, so if all the programmers out there know that exactly what you can do with this kind of stuff, and then also like what the response is. So yeah, this is pretty much how I powered the sort of like intelligence of my robots.
Thank you very much, Sam. That's about all we have time for tonight. Thank you. Give Sam a hand. And yeah, you can meet with us next month to talk about this again. Also, we have the VIGSIG, the Verbal Intelligence Group, is meeting tomorrow night at 7 o'clock Pacific time as well. Does anyone else have any announcements?
I just wanted to say one thing. I thought the question asked about what does it take to be into robotics? And the answer was, oh, you have to be curious about everything. I think you need to be able to work with lots of other people because nobody can understand all this stuff. Example is, I need to do URDS, but I don't have any CAD experience. So how the hell am I going to do URDS? I need to find someone who knows URDS. And look at all the stuff you're adding. You have to find people who know this stuff because nobody can know all the stuff you need to know.
Well, honestly, I'm gonna kind of say join Clearpath. That's exactly why I joined. I knew that the only way that I mean I could go to university, I could blow 80K, but I said, you know what? If I jump into Clearpath, I will learn this stuff, and I absolutely have. And oddly enough, like it's gonna be hard to believe, but if you join this group of people you actually will learn all the things. And I'm not saying you're going to be, God tier expert at absolutely everything, but I've only been there 3.5 years. But I trained. I'm not just there for, a paycheck. I'm not just there to kind of casually have like a job. I was there to train very heavily into robotics because I personally believed that it was going to be the future. And actually, My only thing that I have less left on my checklist to master is the autonomy, and that's a big topic. I've allocated the rest of the year to basically master autonomy. You know, like not just kind of use it as a black box, but to actually deeply understand it. But as for knowing CAD, yep, check. Electrical, I mean, my background is actually electronics. So that was, you know, a previous check. I was always naturally good at computers, like programming, Linux, servers, all that, you know, all that kind of stuff. The LLM stuff has taken me about a year to kind of, you know, master per se, you know, like where I'm at the stage where I can comfortably train models, use like augmented, retrieval, you know, just do all the things that you need to do with it. Like I said, it's been 3.5 years of training, but you can absolutely do it.
Good, I'll call you when I need help with my quaternions.
Oh, good old quaternions. That took me like 3 months alone just to wrap my mind around it.
Financial ending point here. Thomas, you still there?
You're muted, Thomas.
Let's try that again. That ends our meeting for this month. Thank you, everyone. Thank you very much to Sam for his presentation. It was very enjoyable. Again, he's hiring, so anybody who wants to head up to Canada, he's got a job for you. My wife would never want to do that. She likes the warm weather of California. Anyway, we're going to go into random access, and that ends the official meeting. Thanks again, everyone. Thomas Messerschmidt sitting in for Camp Peavy.
All right.